Okay, so hopefully I'm here and back, but anyway, let's go through the review, okay, real quick. So review for tomorrow's test, 1, 9, 19. And if you get, today's 10, sorry, my bad. And if you get stuck, just have me pause it or have the sub pause it, and then we'll go from there, okay? So first of all, number 1, circles. Okay, this is probably one of the easier ones on there. Okay, if it's got endpoints of a diameter of 1, 6, and negative 5, 0. So let's just graph it. If we're not sure how to do it, if we just make a graph, so I'm going to take out some graph paper, and if you don't have graph paper, you're going to need some. Easiest way to do this one is just to get a graph or a picture of it. So, okay, I'm going to go ahead and make a picture of it. Graph paper, 1, 2, 3, 4, 5, 6. There's one end. And 1, 2, 3, 4, 5, 0. There's the other end. So, circle looks something like this. So the center's got to be right in the middle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So 1, 2, 3, 1, 2, 3. Puts the center of the circle right there. Okay, that's good to know. So my center is at negative 2, 3. Okay, so part of the equation, I know this. Part of my equation is going to be this, parentheses, x plus 2 squared plus y minus 3 squared equals the radius squared. Okay, now to get the radius squared, I'm just going to use my picture. Okay, here's my radius right there. So if I make a right triangle out of this, I can get the radius by using Pythagorean's theorem. Okay, a little right triangle there. So I'm just going to go 1, 2, 3, 1, 2, 3. I'm going to go 3 squared plus 3 squared equals r squared. 9 plus 9, or 18 is equal to r squared. So I'm just going to take my 18 and put it there, and I'll have my equation. So I'll rewrite this answer as an x plus 2 squared plus a y minus 3 squared equals 18. Done. That's it. Easy. Okay. Number 2. All right, number 2 is like our warm-up. Write the circle in a standard form, so I'm going to have to complete the square. So I'm going to do this on a separate sheet of paper, so I have plenty of room to do it. So I'm going to do number 2 right here. All right, so let's go ahead and rewrite x squared, put the x's together, minus 10x. I'm going to leave a space. I'm going to go plus y squared plus 4y. I'm going to leave a space. I'm going to bring the 13 over, equals negative 13. Okay? Now, we're going to take half. Half of 10 is 5. 5 squared is 25. Plus 25. So I've got to go plus 25 here also. Keep it balanced. Half of 10 is 5. Square 5 to get 25. Balance it. Half of 4 is 2. 2 squared is 4. So plus 4 plus 4. Okay, so let's see what we get. Alright, so let's see. Real quick. Negative 13 plus 25 plus 4 is 16. And these will factor 5 and 5, so it's really an x minus 5, x minus 5. This will factor 2 and 2, y plus 2, y plus 2. I'll rewrite it in standard form, x minus 5 squared plus y plus 2 squared equals 16. Okay, no problem. Now to graph it, that's no problem. That's easy. To graph it's easy because my center is at 5, negative 2, and my radius is at 4. So I'm just going to go ahead and take a piece of graph paper, and I'm going to get my x-y axis in there, graph it. So let's see, I'm going to go ahead and my center is at 1, 2, 3, 4, 5, negative 2, and my radius is 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I went 4, 4, 4, 4 because my radius is 4. And I'm just going to try and freehand in my circle. Might not be beautiful or perfect, but there it is. There's my circle. Okay? No problem, huh? Okay, good. Again, if we're going too fast, just ask the sub to pause it, and we're good to go. Okay? All right. Moving on. Okay, number 3. All right, again, I'm going to try and use a separate sheet of paper so I've got plenty of room to show my work. Okay? So number 3. Let's take a look at it. So on 3, I see a pair of opposites. If I have my opposites, I can use the law of sines. Opposite, 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 opposite. So I'm going to find angle C using opposites. Okay? So I'll set up, and I'll go sine of angle C over its opposite side is 19. Cosine of 44 over its opposite side, which is 15. Okay? I'm going to multiply up to 19 and get a decimal, and I'll sine inverse it because I need the angle. So 19 sine 44 divided by 15, and I get a decimal. And I'm going to sine inverse that because I need an angle. And I get an answer about 61.6. So angle C is about 61.6 degrees. Okay? There it is on my calculator. Okay? So let me put that in there. 61.6 degrees. Okay, angle B. To get angle B, what I'm going to do is just subtract from 180 degrees. Angle B is equal to 180 minus parentheses 61.6 plus 44, and hold on. Hey, Landon. I'm at school. I'm actually in my classroom. If you can come on up, I'm here, okay? Yeah, pretty soon. Maybe 20 minutes. I'm recording my lesson right now. Okay, bye. Okay. So back to this. That was Landon, of course, because he needs to ride home. So 180 minus 61.6 plus 44. And I get an answer of 74.4. So angle B is 74.4 degrees. I'll put that in there. Okay. And then finally, this side, AC. I don't know AC. Let's call that little b. Same thing with opposites. Okay. So I'll set up here. I'll go, all right. I'll go little b over the sine of 74.4 equals 15 over the sine of 44. Side over the sine of the angle equals side over the sine of the angle. I'll multiply this up. 15 times the sine of 74.4 divided by sine of 44, and I get an answer of about 20.8. So little b is about 20.8. Okay? Centimeters. So far, so good, hopefully. All right, moving on to 4. So 4 says find the area of ABC. Okay, well that's not too bad. To find the area, I need 1/2 adjacent times the sine of an angle. So I just have to pick an angle since I know them all. I may as well pick, let's see, B was 20.8, right? So if I pick my 44 as my angle, then I'll use my 19, I'll use my 20.8, and it's actually pretty easy, okay? So, I'm going to go 1/2 19 times 20.8 times the sine of 44. Let's use my calculator. 0.5 times 19, that is a 19, times 20.8 times the sine of 44 degrees, 137.3. 137.3, and that's in terms of centimeters squared. Okay? All right. Number 5. Again, I'm going to use a separate sheet of paper just so that I have plenty of room to show. So let me slide this up, okay? All right, first of all, it doesn't really matter. I've got to pick one angle. I may as well pick this angle. Since I don't know any opposites at all, I'm going to have to use the law of cosines, right? So in 5, I'm going to pick y. That makes the 20 and the 18 my adjacent sides and the 21 my opposite. So it sets up like this. Cosine of angle y equals parentheses 20 squared plus 18 squared minus 21 squared parentheses divided by parentheses 2 times 20 times 18. All right, I'm going to put that in my calculator and I'll get a decimal. Then I'll take the inverse of cosine to get that answer. So I'm going to go parentheses in my calculator 20 squared plus 18 squared minus 21 squared parentheses divided by parentheses 2 times 20 times 18, and I get a decimal like I thought. And then I'm going to do the cosine inverse of that answer to find my angle. Cosine inverse of that answer, and I get about 66.9. Okay. So far, so good. Now, you've got two choices. You could do the law of cosines again. You could do the same formula again if you wanted to for either x or z, and that works. I'm going to use the law of sines because I think the law of sines is easier to do. So I'll do the law of sines instead. So with the law of sines, I'm going to set up my opposites, right? Let's pick x. It doesn't really matter. So I'll go sine of angle x over 18 equals the sine of 66.9 over 21. Okay, opposites. Angle, opposite side, sine of an angle, opposite side. I'll multiply up the 18 and I'll get a decimal. 18 sine 66.9 divided by 21, and I get a decimal because I want to do the sine inverse because I'm looking for the angle. Got that. So I'm going to do sine inverse of that answer. Sine inverse of that answer. I get about 52 degrees. 52.03, so I'll just say 52, okay? Now, since I have 52 degrees for angle x, then angle z is very easy. Angle z would just be 180 minus my 52 plus my 66.9 degrees. And I'll go ahead and do that. 180 minus parentheses 52 plus 66.9. I get about 61.1 degrees. Okay, that's not too bad. Alright, 6. Here comes the big problem. Let's do it. Okay, bit by bit. I'll draw it slowly. Okay, I'm going to do it on a separate sheet of paper. And I'll go through it slowly. Okay, so first of all, let's make angle A. So I'll just put a point down here, call it A. I'm going to draw my terminal side of my triangle. I needed a 35-degree angle, so I use my protractor. Zero it out. 10, 20, 30, 35. Okay. I'm going to draw this length 7. Okay. So I'm going to draw side B, 7 centimeters. And I got it right about there. Okay. So this is side B at 7 centimeters. Okay. This is 35 degrees, which is A. Now, side A, it's got to be over here. We're going to attach it, but we want it to fit. So I'm going to take my ruler and make it fit. So 5 is right about there. Okay, and that's little a. So side B, angle B, angle C, and side C. Now, we will draw the other triangle and figure that out as soon as we figure out what the big triangle is, okay? So let's call it the big triangle, okay? Alright, step by step. So, big triangle, okay? First thing, let's find angle B, okay? So, let's find angle B. So we'll go sine of B over its opposite, 7, equals sine of 35 over its opposite, okay? And then I'm going to multiply up the 7. I'll get a decimal, and then I'll take the sine inverse. 7 sine 35 divided by 5, and I get a decimal. But I'm going to take the sine inverse of that, of my answer, sine inverse of that answer, and I get about 53.4 degrees. So angle B is 53.4 degrees. Okay, let me put that in here. 53.4, okay? Now the second thing I'm going to do is find angle C. So from 180 degrees, all three angles add up to 180. So I'll subtract out the 35 and the 53.4, okay? I just use my calculator. 180 minus 35 plus 53.4, and I get an answer of 91.6. Okay, I'll put that in there. Okay. And then finally, I need this missing side AB. To get this missing side AB, I'll set up the law of sines again. I'll do the opposite. So side C. Okay, third thing I'm going to do is go side C over the sine of 91.6 degrees equals, we'll go 5 over the sine of 35. Multiply this one up here, and I'll just use my calculator. Okay, so I'll go 5 times the sine of 91.6, close the parentheses, divided by sine 35, and I get an answer of about 8.7. Okay, little c is about 8.7 centimeters. Alright, now, got the big triangle. Good. Let's find the other one, okay? So I'm going to find the other one by drawing my 5 here, because I need to follow the directions, and the 5 is right about there, okay? So let me make my orange triangle. So this is the triangle now that I want to find, okay? So let's call that the small triangle. How's that sound? Okay, so we'll put that work over here. Let's call that the small triangle. So angle B is no longer here. Angle B is now over here. Here's angle B, and that's what I want to find, is that angle. Okay, now how do you do it? Well, it's really not that bad, because I know that these are both 5. So if this side's equal to this side, it's an isosceles triangle, which makes this angle, this base angle, equal to this base angle. So this is also 53.4 degrees. Okay, I want angle B though. I don't want that angle, because that's not part of my orange triangle. So I know I've got a straight line, which is 180 degrees. So the first thing I'll do is take angle B is equal to 180 degrees, because of a straight line, minus 53.4 degrees. Okay, 180 minus 53.4. I get about 126.6 degrees. All right, I'm going to put that in there. 126.6. Okay, now in the triangle, this angle C is no longer 91.6. It was for the big triangle, but now angle C is this smaller angle. So, but I'm going to do the same process. The second step I'm going to do It's the exact same process here except for with different angles. Still going to be 180, but minus this time 35 plus the 126.6 degrees. Okay? 180 minus parentheses 35 plus 126.6, and I get an answer of, hold on, 180 minus parentheses 35 plus 126.6, I get an answer of about 18.4. Okay, is angle C. Okay. Okay, now angle side C is no longer this entire C side. It's just this little bit here. It's AB. So I want to find it using the same process I did on the big triangle except for different numbers. So I'll go little c over the sine of its opposite angle, but this is an 18.4 degree angle, equals 5 over the sine of 35. Okay, multiply that up. 5 times the sine of 18.4 divided by sine of 35, and I get an answer of about 2.75. Okay, that's the big one. Hopefully you guys can do that tomorrow. We've practiced it many times. Okay, let's whisk this away, and we'll look at the back side. Okay. All right, number 7. Here's a regular pentagon in a circle. So what I want to do is find the radius of the circle, which would be this length, that's the radius, and the area of the pentagon. So let me tackle it by doing this. What I want to do is superimpose this triangle there. And I'm going to go ahead and draw that on a separate sheet of paper. Okay, so I'm going to go ahead and just do this. What I want to do is find this triangle here. Okay, I want to find the radius, and I know that each side is 22, so this is 22. Okay, 22, 22 all the way around. 22, 22, 22, 22, 22. Do you guys mind answering that, please? Mind just say Mr. Davies busy? Now, I want to find this angle here, theta, right? And I know that in this pentagon, if I go around a circle, there's a total of 360 degrees to find the angle. 360 degrees divided by 1, 2, 3, 4, 5 angles. So 360 divided by 5 is 72 degrees. Okay, so let's put 72 here. What was it?
He said his name is Gary SB, and he thinks he has the one.
Okay, thank you for grabbing that. Okay, so here's what I have so far. I got 72 degrees. I've got 22. I don't have a whole lot of information, right? But if I break this triangle right down the middle, okay, and I make it into a right triangle, let's see what I have. Okay, this is now 11. This is 36 degrees and R. Okay, now I can find the radius. I can go opposite over hypotenuse. I'm just going to use regular right triangle trig. So I'm going to go sine. So I'm going to go sine of 36 degrees equals the opposite over the hypotenuse. To solve for R, I'll multiply up the R. R times the sine of 36 equals 11. Divide by the sine of 36. And I'll just use my calculator because that cancels that. I'll go 11 divided by the sine of 36. And I get about 18.7. So the radius is going to be 18.7. Okay, let me go back to my picture, okay? So my picture looks like this. My original picture of my orange triangle. Okay? I know this angle is 72 degrees. I know this is 18.7 and this is 18.7. Okay, I can find the area of this triangle. I can. because I know it's going to be 1/2, the area of this is going to be 1/2 adjacent times the sine of the angle. So 18.7 times 18.7 times sine of 72 gives me the area of the triangle. Okay, so I'm going to go, okay, 1/2 times 18.7 times 18.7 times the sine of 72, and I get an answer about 166.3. But that's just the triangle. Okay, that's just the triangle. Now let's take a look. Okay, if I go back to my original figure, okay, my original figure is a pentagon. So there's 1, 2, 3, 4, 5 of these triangles. So I'm going to take my pentagon, is going to be 166.3 times 5. Okay, and I'm going to multiply that by 5, and I get an answer of about 831.4 centimeters squared. Okay, you can do this. This is a little bit of right triangle trick. Okay. All right, you ready? Last but not least is our ship problem. Okay, let's see if I can go ahead and draw a picture. Okay. So we're going to go northeast and southeast. So let me put port somewhere around. Let me get a separate sheet of paper. Let's put port maybe right about here. There's my port. Okay. And I'm going to go ahead and grab my protractor. Put my compass rose in there just so I get my north, south, east, and west. I just like to have my compass rose. Okay. Alright, last problem. 2 ships leave at the port at the same time. Ship A travels at a bearing of north, okay, north 42 degrees. So 10, 20, 30, 42 degrees, okay, 0 degrees, 42 degrees towards the east, 9 knots. Okay, so I'm going to use my ruler and draw this 9 centimeters for 9 knots. Okay, there's ship A. This is 9. This angle is 42 degrees. Okay. Ship B is going to go on a bearing of south 18 degrees east. Okay, so I'm going south, and I'm going to go 10, 18 degrees is right about there. Let me scoot that up so you can see it. Okay, 18 degrees is right about there. I got 10, 18 degrees is right about there. And I'm going to go 7 knots. So we can make this 7. There's ship B, and I know this is 18 degrees here, and this is 7. Okay, so how far away are the ships? Let's see. Okay, they're about that far. However, they're going to travel, aren't they? In fact, they're going to travel. How far are the ships apart? Oh, I don't have to multiply anything. Okay. Oh, 4 hours. Sorry. So 4 hours. So I'm going to multiply this by 4 and this by 4. 36. 28. Okay. So that's my length. So go for 4 hours. Now I need to know this angle. Okay. I need to know this angle. So I know between north and east is 90. So I'm going to go 90 minus 42. 48 degrees there. And I know between east and south is 90 degrees, so 90 minus 18 is 72. Okay, I need the entire angle of this triangle, so I'm going to add those together. 48 plus 72, and I get an answer of 120. Oh, that's convenient. I like that. Okay, now, let's find this length C. All right, law of cosines. Here we go. Law of cosines is going to be C squared equals 36 squared plus 28 squared minus 2 times times 36 times 28 times the cosine of 120. Okay, I'm going to use my calculator. 36 squared plus 28 squared minus 2 times 36 times 28 times the cosine of 120. Okay, and I get c squared is equal to 3088 square root, and I get an answer of about 55.6 knots. All right, now comes the challenge question, okay? If ship A is disabled, what bearing must B take to rescue ship A? So ship B is going to travel along this course. But the first thing B does, and I'm going to go slowly with this, first thing B wants to do is look at his compass. So B's going to look at his compass. So he's going to go, okay, well, let me look at my compass. So if I look at my compass, what ship B needs to do is set a course on this angle there off of north. So that's the angle I need to find, is that angle here. Let's just call that angle theta. I need to find that angle off of north, okay? To do that, there's a few things I know. Okay, I got to go back to geometry, and to go back to geometry, I know this. 72 degrees. See the 72 degrees? I don't know if you remember alternate interior angles from geometry, but let me go ahead and draw a picture for you so you see it, okay? All right. I don't know if you remember this from geometry or not. Okay. So this angle is 72 degrees, okay? Which means this angle here has to be 18. In fact, you can see that same 18 there, okay? Okay. So what I'd like to do then is if I can find, there's 18. If I can find the entire angle, all of angle B, subtract 18 from it, I'll have theta, okay? So here's what I'm going to do. I'm going to find theta by going, finding angle B. I'm going to go angle B, which is all of it. I'm going to subtract 18 degrees. Angle B, and I'm going to subtract 18 from it, and that will give me theta, which is going to be the direction I need to take. Okay, so to find angle B, I'm going to do my opposites. See, I know this side now is 55.6. Okay, so let's set it up. Okay, I'm going to set up the sine of B over 36 equals the sine of 120 over 55.6. Okay, multiply up the 36. 36 times the sine of 120 divided by 55.6, and I get a decimal. Thought so, because I'm going to take the sine inverse of that. Answer. Got a decimal. Take the sine inverse of that. Sine inverse of that answer. And I get about 34.1 degrees. Okay, now let's think about this, okay? Okay, the whole angle, this entire angle now is 34.1, okay? I want theta. So I'm going to take 18 away from it. So I'm going to go, okay, theta, that's that angle there, off of north, is 34.1 minus 18. So 34.1 minus 18, I get an answer of about 16.1 degrees. So, on my boat, I'm going to say, hey, Captain, here's your bearing. But you go north and turn 16.1 degrees towards the east, and I'll be able to rescue ship A. Okay, that's all I have. You have homework. Please do it, because there's other problems that aren't on this review that are on the homework. Okay?